So let's see the correction of this question. So you have a 0.1 molar ammonia solution in a flask titrated with 0.1 molar HCl. So this HCl is placed in the burette. So this is a weak base, strong acid titration. So explain why the pH of ammonia is less than 13. So you're given the concentration of ammonia. So based on the concentration, we know that ammonia is a weak base. Therefore, the concentration of OH minus in a solution of ammonia is going to be less than 0.1 mole per dm cube. So this is the concentration of the base, but the concentration of OH minus is going to be less than that because it is a weak base, so it dissociates only partially, which means that the pOH that we calculate is going to be greater than 1. So the pOH is going to be greater than 1. And because pOH is greater than 1, this means that pH is going to be less than 13. Estimate the pH at equivalence point and explain your reasoning. So because we have a weak base, strong acid titration, therefore the salt of a weak base, strong acid is going to be an acidic salt. So let's write the equation for this. So here you will have a reversible arrow. Now this is a weak base. Therefore, this is going to be the conjugate acid. And because the base is a weak base, the conjugate acid is going to be a strong conjugate acid. And because it is a strong conjugate acid, it's going to release H plus more easily. Because H plus is released means that the pH of the salt solution is going to be decrease, so it's going to be acidic. So here you can say the salt is acidic because you have NH4 plus, which is present, and NH4 plus is a strong conjugate acid. Therefore the pH here is going to be any value from 4 to 5. So you could say pH is equal to 5. So any range from 4 to 6. Now this is the equation for the reaction between ammonia and water, and write the Kb expression. So in water, ammonia is going to release OH minus ions, and this is a reversible reaction. And the expression for Kb is the concentration of products over concentration of reactants, of course without the concentration of H2O included. Now, when half of the ammonia has been neutralized, so half equivalence point, the pH is given. So at half equivalence point, we know that pOH is equal to pKb. So here the pH is given. Deduce the relationship between concentration of ammonia and ammonium ions at half equivalence point. So at this point, half equivalence point, the concentration of the base and the concentration of the salt is going to be the same. At equivalence point, all the ammonia is going to be used up to get only the salt, but at half equivalence point, you have half of the ammonia that has reacted and it has produced an equal amount of salt. So the concentration of the weak base and its conjugate acid will be the same. Now determine the pKb and Kb value for ammonia. So at half equivalence point, we know that pOH is equal to pKb at half equivalence point. We have been given the pH. From the pH, we can get the pOH. So pOH is 14 minus the pH value. Therefore, from the pOH value, we can get the pKb value. So pKb value is just 14 minus 9.25. And that should give you the the pKb value. From the pKb value, we can get the Kb value. So you can just do 10 to the power of minus pKb. So this is the Kb value.